what to do with your legacy data when switching to SolidWorks. My name's Quentin Rock and I'll be the presenter here. Let's go ahead and jump into our next slide. Just a quick agenda of what we're going to do. I won't kill you with slides here, but I do have a few. Basically, I just want to start out with what is legacy data? What are we talking about when we say legacy data? And then review some of the file formats, and then review how SolidWorks and its products handle the legacy data that once we've defined it. And then, of course, any questions at the end, if we have time, I'll get to. Otherwise, feel free to type those in as we go. You don't need to hold your questions till the end. I kind of consider the legacy data anything pre-SolidWorks. We can consider it that way, whether it's 2D or 3D. So we'll go ahead and take a look at both of those. We'll start out with some 2D stuff. But before I go to that, basically, when I talk about the miscellaneous, I just wanted to also define that. Like I said, it could be consulting data, something that you're getting, but you don't really have the native CAD files, or maybe you do, but you don't have anything to open them with, or even JPEGs, or old school drafting on a board, vellum stuff. So anyway, so SolidWorks can basically interact with all these different file formats, and they do different ways, and it depends on different versions and stuff of some of these. So there are some restrictions to these, but for the most part, this is pretty much the summary list of what file formats are available to either import, export in SolidWorks. Our most common ones, as far as universal file formats, are going to be for the 3D type stuff. The Parasolid, Step, and IGES are probably your most common ones. You'll see almost every CAD package out there have an ability to do one or all of those. And then DWG, DXF are going to be your 2D common ones. The rest of these are are different things. The 2D images or JPEGs, we can insert those and trace over them, put them in as logos. If we do some photorealistic rendering with Photo V360, we can use those also. So there's a lot of different types of files that you wouldn't normally consider CAD related, but you can see there's a pretty wealth of different file types in there. So let's talk about the 2D data first, and then we'll go ahead and get into some of the 3D data. And before I do, I wanted to mention a product called DraftSight. Basically, summary real quick, and the reason I bring this up is this is a great tool for DWG, DXF type files. It's what you might consider an AutoCAD clone, basically. If you go to DraftSight.com, and you can see download for free. It is free. It's 100% free. Let's go ahead. I'm going to switch over to my my desktop here and just launch it up, and you'll see the interface. And it's adjustable, similar to SolidWorks, where you can go in and adjust toolbars and everything. But you'll get your basic admin or your AutoCAD type clone look, or your DWG editor type look, where you can go in there. And this has a great community of people out there, forums, support. Can also, if we see if I have any files quickly here I can grab, but I can open these things up, I can edit them just in there. So step one with 2D DXF stuff is maybe you don't need to convert it over. Maybe you can just use DraftSight. Our enterprise PDM package has viewers for it as well, so you can manage the data still, and it understands that, and build cards and everything with it. So the 3D or the 2D DraftSight is a free alternative to AutoCAD. So if you're just keeping a copy of AutoCAD around, or you're trying to free up some budget to buy SolidWorks, you can use the free DraftSight and maintain that legacy data. That's really the theme you'll see with several things. I'm not going to go into a DraftSight demo here, but go ahead and take a look at that. Okay, so let's jump into SolidWorks and see what SolidWorks does. So inside of SolidWorks, you can file open, and I showed you all those file types, but I'm just going to leave this up for a second here. You get an idea of all the different file types, and some of these kind of have subcategories even, and different extensions for more than one type. But you can see there's a wealth of those again. In this case, I'm going to open up our 2D, and I believe I have DX, yeah. And when you open these things up, we'll go through the different options. So I just go File Open, I switch it to the type I want, or all file types, and then I get this DXF DWG wizard. And what this does, this asks you questions of what do you actually want to do with this data. if I want to convert it, it's a drawing, and let's say I already have I built some parts in SolidWorks, but some of these parts are library components, or we built them 10 years ago. We have the drawings for them already. I don't want to redo this just to make the drawings. Maybe even if it is simple, I can just convert it into a SolidWorks drawing and then add it as a page 2 or a page 10 or something in my set of drawings. So I don't actually need to do any real work with these things. And if I hit convert to SolidWorks entities, it'll actually create it the SolidWorks entities and try and map everything to SolidWorks entities. Take an AutoCAD line or AutoCAD text and bring it over. And I'll hit next on this, and we'll take a look at what that gives me the options to. So I can just say bring in all the layers. I can shut off layers. I can pick certain layers to go to the sheet format, or what we call our title block type thing. That's sort of like the model and layout type look. I'm just going to go ahead and accept the defaults here. I can kind of center it in the page and position it around, and you can see scales and fonts and things that I can change. But let's just go ahead. I'll hit finish on this just so you can get an idea of, yeah, it's in there. I'm not sure how well this colors are showing up. We have layers, toolbars, and things I can turn on. So I'll go ahead and just show you that even though I converted it over to a SolidWorks drawing, I can go into my layers, and let's take this, make them black, and take a couple of these colors that may not show so well over the web at least, and make them black. And you can kind of get the idea that I basically don't really have to change a whole lot. Provided these dimensions weren't fudged or something like that, which was a common practice back in the AutoCAD day. Instead of redoing it, you just change the number, right? But anyway, so then I can change out my title blocks and things like that if I want to match the rest of the ones in the drawing or the current drawing set. But really, you can go right into SolidWorks with that data. You don't need to redraw it if that's your only case. Now that's kind of the 2D thing. I'll go ahead and I won't save this one, and let's open that same file and look at the other options we have in there. Again, switching it to the different file type. It's easy, no special import or anything like that. I can embed this into a SolidWorks drawing. So what this actually does is it kind of just sticks it into the drawing without actually converting it to SolidWorks entities. So there's sort of like a viewer type thing, and it'll just be on a sheet, and it can be any sheet in the drawing, so you don't even have to do the conversion. Every once in a while, you use some crazy font or something that no longer is there, and then when you're trying to convert it over to SolidWorks, you have to try and map and find the font that is closest to it, or go back and download it and install it in your Windows. So there can be issues there. So sometimes you'll want to just leave it the way it was and embed it in there. Remember, again, you can always do this in DraftSight and not even bring it in. So those are some options if we don't want to really do a lot of changes to it. We just kind of want to. The drawing's done and it's good enough, and we need to move along. The next option here, and I'll just show this, the 2D sketch part, is I can bring it into a part. And in SolidWorks, for those of you who are newer to it, basically you kind of have your 3 environments. Your parts, you take those parts, put them together in assemblies, and then you take the assemblies and the parts and you make drawings of them, 2D drawings. And it's fully parametric and everything that you would expect with a 3D modeler. But what we do with the parts is basic 3D modeling is you take a 2D sketch and you give it a volume. You extrude it, you cut into it, you chop away, you revolve, many different types of modeling techniques. But so we can do that. We can import this into a 2D sketch. I'll click next. Again, I get my preview window here, and there's a bunch of zoom, all kinds of stuff, so I know the fonts are really small. But in this case, what I'm actually doing is I'm going to consider making this into a part. I want to rebuild this in SolidWorks, and I want to save time by getting the exact dimensions and everything that was done in here. So I don't want all the layers. It's not going to hurt to bring them in because I could just delete them or I can hide them, but there's no sense in doing that. So I'm going to turn off at least the title block and stuff. I'm going to add constraints to it and add dimensions. So in SolidWorks, when you build a part, you add relations. You tell this line to be vertical. You tell it to be perpendicular. You tell it to be an inch long. And those are all kind of constraints and dimensions. So I'm going to bring in any of those that were in the part, any of that intelligence that was already built into it. I click Next, and pretty much, again, I can run some different options and adjust several things, but I'm going to go ahead and just accept the defaults and hit Finish. It warns me that there may be some blocks in here. Go ahead and explode them. Because what we're actually doing here is what it does is it just creates a sketch on our front plane. You can see on the bottom left there, the positive XY plane, basically. And it put in dimensions, it put in SolidWorks entities. You can see they're all in blue, which means there's some underdefined. And really what it is the placement in space. And what it does by default, or if you've already have this turned on or turned off maybe, is it brings in this 2D to 3D toolbar. These are all commands you can get in the tools menus, but basically this is a special toolbar. So if you're bringing in a lot of this stuff, you can turn it on like any other toolbar. You can see the million different ones we can turn on. I'll just go ahead and dock it back over to the side so it's out of our way here. And what you do is you basically just pick portions of this to make the front, make the top, make the left and views. So I'm going to just do a box select, like a very familiar command there, and make that the front view. And you can see it sort of grays it out. It's sort of okay. Now you've defined that. What do you want to continue defining it? Now that I've defined that, I can say make that the top view. And you see it sort of orients it. And if you look over in the feature manager tree, it's actually taking this one sketch and converting it into two sketches on the planes that were there. Now they may not match up or anything, so if I kind of scroll this in 3D and see, well, it rotated it over. So there's tools for that. I can control select a couple lines here and say align those. So in SolidWorks, basically all you have to do now is extrude it in this particular part. And if I hold down Alt, it'll let me grab that, and basically I can see that I've made this part pretty quickly. Now I know this is a pretty simple part. Those of you who've used SolidWorks would realize that it probably took me longer to explain this part than it would take to build. But the point is you can bring it across. I like to do that a couple more times and show you some of the different options in here. So let me just go ahead and open another one. And again, these are SolidWorks parts. So let's pick this guy this time, and we'll import it apart. I'll go a little faster here. I'll just again turn off any layers we don't need. I do want that one. Looks good to me. I'll hit finish. So basically on this particular part for SolidWorks, all I really need to do is just rotate. This is do a revolve command. So pretty much if I just turn this for construction, pick this contour select and then hit the revolve button, I can revolve 360 degrees in there, and I really don't even need the rest of this stuff. I don't even need to make it a top or a front view. So you can see right away I've quickly gotten I've made this part in seconds that it would take me. Now even though it'd be easy to remake that in SolidWorks, I still have this sketch, I still have all the dimensions, they're still all there. So really easy to bring that in. Again, a very simple part, but just to explain to you, you don't always need to use all the tools that are there. You just need to find out what your goal is. The last part I want to bring in just to show you that it does have the ability to do a little bit more complex stuff, because as I mentioned, this is pretty basic parts. We'll just bring this one in. Yeah, go ahead and explode them. I should have exploded those before. So again, this is a little bit more. I do need something from all the views. I'll make that the top view. I'm sorry, make that the front view, make that the top view, make that the right view, right? Oops. Again, we can use these tools, so I can come in here and let's see if I can do this without zooming in here. Pick a couple entities here. I'll pick this guy, and I'm sorry, this. My bad eyesight, forgive me. So I can give them front, top, and right. Now I can do the same sort of thing I did before, where I take this sketch, extrude at a certain distance. I'll inference this line so I know I'm going exactly where it needs to go. And then what I need to do is use this to cut. So I'll use some of my basic commands, the extruded cut. I want to go through all. Of course, I want to flip the direction, so I want to cut everything away, not that's there. So as you can see too, as I'm designing this is probably a sheet metal part. SolidWorks handles sheet metal very well, as many of you know. I can click the convert to sheet metal button, pick the face I want, collect all the bends and hit OK, and if I hit the flatten button, Now I flattened it. Now tell me that you could have done that with your DXF by modifying it, your 2D. It would take a little bit of time. So SolidWorks is very smart about being able to recognize features that are already in there. So I didn't even have to worry about changing the bend radius or making sure it worked because the part was already built in working form at some point in time. I just converted it over. So if we want to go ahead and just finish this step, I would just unfold the part. I want to make this rounded front here, so I can kind of go normal to, and we'll take that edge here, convert it into the sketch. So it's a pretty simple process. Basically, all I'm doing is just taking this, and then I'm just going to do that same thing. We'll just chop off the end of it. Make sure we cut the right side away that we want. You can see. Oops, flip side to cut. Yep. The little arrows indicating it. So now that I've cut that part, all I have to do is turn it back into it. So even though this is still a somewhat simple part, I was able to take it from a 2D DXF, a legacy data, convert it over and bring it in, and you can see it does a pretty good job. The other thing that the other benefit, of course, of 3D is if I pick a certain material, it has these properties. In SolidWorks, obviously, I'll just jump in here real quick to show you. There's hundreds of materials in there, a lot of the most common ones, and you can even make your own custom one if you didn't find one. But now I have weights and types of things, and if I want to come in here and I want to change these holes or do anything like that, I have it in 3D. I can make my drawings of this. I can show these flat pattern views, with the bends and everything. So a really great tool to do it, to convert your 2D DXF, DWG type data into these items. All right. So that was kind of our 2D data. If we jump back here, let's talk about our 3D data. And again, if any of you guys have any questions as I go here, please feel free to type those in. 3D data is a little bit more tricky, but basically it's just as simple, if those don't contradict what I just said too much. Basically, let's jump over and take a look in SolidWorks again. Now, instead of opening these DXF or DWG 2D files, converting the entities to sketch entities, and then using those as the fundamentals of my part, I'm going to go ahead and bring in a file. And I've got a Parasolid. By the way, the Parasolid is one of the best ones for SolidWorks because of they're built on the same kernel. SolidWorks is built in the background on the Parasolid kernel. Obviously, there's a lot of CAD packages like that, but anyway. So when I go ahead and open it, it says, "Would you like to run import diagnostics on this part?" I'll go ahead and say yes, and it finds no faulty faces or anything like that. So nice tool built into SolidWorks when you import data that will check it. It'll say, hey, this import didn't come across that well. That their translators or our translators, or we can point fingers all day, but basically your part was not something didn't translate very well. There was an item or a face. This one came in perfect, and it's obviously a simple part. I'll rotate it around a little bit, take a look at it in there. But again, if there was a material to it assigned before, I can come in here and assign a specific material like a brass or any other. These are just my favorites, but you saw there was several hundred of the other types in there. So now what do I need to do? And this is where I get into arguments with people, or I try and stop people from the common mistake of thinking that something's wrong with this part because it wasn't created in SolidWorks. I converted it to a SolidWorks. When I hit save, it's going to prompt me to save it to a SolidWorks native format, the part format, and I can hit save, and now it's a SolidWorks file with whatever name I decided to give it. In this case, mounting block something. But if this part's good, you've got it. You're done. You don't need to do anything. I can take this part. If I need to make a detailed drawing of it, if I don't already have one, I can insert it into SolidWorks drawings. Let's just bring it in here. Front, drop a top view in, a right view. Basically, I can do anything that I was able to do in SolidWorks. I can do that. I can start putting dimensions on if I want an overall length or height or something like that. I can start adding that kind of stuff in there. A lot of things I can do as far as using this part the way it is right off the bat. What the common thing is, though, is we need to change something on this, right? So let's jump back over here and say, okay, what is it that we need to change? There's a lot of tools. If you notice the features toolbar, this is why I argue with people that you don't need to do everything. You don't need to recognize every feature in here as something that SolidWorks understands and makes it easy to edit, because you may not need to edit it. This probably could be built in 3 or 4 features in SolidWorks by a SolidWorks user. But the toolbars here, you'll see almost everything is lit up. There's very few things you can't do right now in SolidWorks as far as cutting away, adding material, doing it. There's even some more complex tools where I can come in here and do insert features flex here, and what flex will do, or deform it, or put a dome on it. You can see all the different types of tools. They're not grayed out. I can use all those tools. The only ones that are not grayed out, and these would not be grayed out because something like combine needs multi-bodies to combine them together to add or subtract the parts together. So there's literally everything is open. Your whole SolidWorks toolbox, your whole toolkit basically is there. So let's go with some common things we might want to change on this. Maybe we want to change the fillet. So what I can do is get rid of this face. So I can insert face, delete. And I can say delete and patch it. If I click OK, it gets rid of just that fillet. If we go back and edit it in SolidWorks, very easy to edit. I can pick a few faces here. See if I can get all the right ones with a quick select. Nope. So I can pick several of these faces and say, you know what, I'm going to add a fillet. Whatever this fillet was, it wasn't the right one. So I go ahead and delete those faces. Let it patch up. Am I missing one? Let me see. Sorry, I might have missed a face here. Let's just do this half or something. So basically, I can go through and I can get rid of faces. Now it doesn't have it on there. If I want to come in and add a new fillet to it, I can come in and just say, okay, this fillet's going to be 0.5 or something like that. Add a bigger one, a smaller one. Let's make it 0.3. Obviously the values still have to work, but you can see I can change just that one thing in there. If I want to make this part or this hole, let's say it's the wrong size hole. It needs to be larger or smaller. Now I can just fill it in because it's a countersink. Maybe all I do is I start a sketch. I use that same convert entities that I did before. I just fill that hole in. Make a extrude that does that. SolidWorks automatically combines that into one. Now I don't have a hole in there. So now all I have to do is either create a new hole or use our hole wizard commands. Let's jump over here, hole wizard. And the hole wizard itself will go through. It's got a library of different types, maybe the countersink, and I want to change it to a different size one. I'm not sure what we had in there before, and then I can position it. Just go ahead and click to position it, and place it somewhere if I want to place it dead center, that kind of stuff. Now I've just changed the hole. I can do this in this part. I can do it in configurations. You can see like that same delete face command. Let's say I didn't do that. That same delete face, I can come in here and say, I want to go ahead and delete those two also. And that would have filled it in. So plenty of tools in here for it. The more you know in SolidWorks, the easier it is to edit these things. If I want to make this thing longer, let's say I just want to move this stuff. So let's go back to where it was when it first came in and say, let's do this. Let's leave the let's just get rid of this hole. Sorry, bear with me 1 second. And say I want to make it longer. I can take a part and split it, and then take this body and then move it. So bear with me. And we'll just give it an actual distance. Let's just say we needed to make it that much longer. I don't know what value that was. I didn't check. So then I just take this face, start a sketch, and do that same thing. Convert entities, extrude it, and we'll make sure it goes up to the surface, and we're done. So I've just made this part longer. So again, this is a simple part, but it's called direct editing, and you've heard this term before. Direct editing means that like you don't have to go back to the feature-based history here and adjust it. And that's a big term in the CAD industry. It's really not that important probably in most cases, but having the option, SolidWorks has had a lot of these tools in there even way before somebody coined this direct editing term. And you can see the move copy, the move face, all the things that I've been doing. Basically, those have already been in SolidWorks for a long time. So the idea behind this is, yeah, you can go ahead and recognize some of the features or rebuild it, but remember, just like the DXF, maybe you don't need to. Maybe you only need to change a few holes or one half of the part, the arm. Maybe just chop it off or something like that. You get this again. We'll go back to the let's go back to the original part where nothing was changed on it. I'll delete everything out of there, all the work I just did, and now we're back at the original imported part. There is no feature history tree to it. So again, this might be enough. Maybe I want to shell this thing out or something like that. I can use all those commands, but you could build this pretty easily. You can make drawings using your assembly. So really, again, if all I need to do is change certain things or 25% of it, even if this was a native SolidWorks part, for some of you who've been using SolidWorks for many years, if you go back and you have a very large component that has a lot of features, some complexity to it, if you go back and edit some of those things in any modeler, you risk the odds of it breaking something down below it. The parent, if you change the parent, the child might change. So that's the same in SolidWorks. You can use these direct editing tools on your SolidWorks files that already exist. You don't have to go back and edit the whole tree. Now, sometimes it's easier or harder to follow if you've done that, but it's definitely a common practice. Whether you want to go back and fix this part for 4 hours or something, or do you just want to spend 5 minutes and use some of these direct editing tools and change it. So, very common thing. Last thing I want to show you guys before I let everybody go, and let me see if there's any questions here. Nope, not so far. Is I just want to show an added in SolidWorks that helps recognize features. Is it 100% perfect? No, but it works pretty good on our prismatic type parts. Things that are very, machine oriented or, probably made on CNCs very well. Those kinds of things are going to be pretty well. It's called FeatureWorks, and what FeatureWorks will do, and it gives you a little tooltip there. It says it's feature recognition for imported parts. It only works on imported parts. It only works when you first start into the part. You don't turn it on after you've already got the part open and cut away a bunch of material and done a bunch of work on it. You do it when you first import it. And the idea behind it is it's supposed to go through and it'll automatically or manually recognize features. And then it'll put it in the tree here so you can actually come up with a feature tree. FeatureWorks is available in the SolidWorks Professional bundle. So if you just have the standard, you probably won't have this tool, or you will not have this tool. I shouldn't say probably. Insert FeatureWorks. There's some options to it, so I can tell it things like add dimensions to the things. I leave them pretty much the defaults, but there are some things when I'm actually creating these, create new file or override the existing file. And I won't go through them all here, but one thing to check if you use it. But basically, there's two buttons. You hit Recognize Features. If I was to turn the toolbar button on, and you can say standard features and recognize all these types of things. Now, it's not without fault, but I would say at least half the time or more on these parts, it'll recognize them. I personally like to use the interactive type stuff because I like to define these a little better. I like to group them a little better. It's easier to do grouping, and you can use a combo and go back and forth between the two, believe it or not. So in this case, I want to recognize a fillet. This is a pretty standard constant radius fillet there. So I pick a face on there, click to chain the fillet faces. It's already doing some work. You can see it picked up 12 faces just on that. I hit recognize, and what the way FeatureWorks does is it basically takes those fillets out of the part now that it recognized them. So it's kind of like it turned it off. So now you can go ahead and recognize your next features. And if I hit the next button, you can see I have a fillet it's recognized, and there's still this unrecognizable body. So I'll go back, and we'll say next, we'll get rid of this hole. So the hole works pretty good on standard holes. I'm going to go ahead just to show you some different stuff here. I'm going to call it a cut revolve instead. and just select these entities here and say, recognize this as a cut revolve. If it removed it from the list, it did. If I hit next, you'll see now that it's recognized a fillet and a cut revolve. And the reason I go to this is because you could actually have it combine features. So if later on I find another fillet of the same type, instead of adding 5 fillets, I can say they're all the same radius, combine them all. In this part, I'm not really going to do that. So a couple features we have left. I can do this extrude and try and recognize it with draft. I'm going to go ahead and just put a draft in there as well and say this is going to be my neutral face. So I'm going to say this is the faces I put draft on, and recognize that. You can see it's removed the draft out of that. So now if one of my goals was to change this from, I don't know what it was, a 30-degree draft to a 45-degree draft, I can do that now very simply. And the last but not least is we want to recognize the boss extrude. So the selected entities and the up to face. So it doesn't matter. I'm not sure where it's our front plane. I'll just say that's where we're going to start it. And then we're going to go up to this face. And probably we didn't even need to click most of these things. It probably, if I just pick one face. Now, you'll notice it jumped me to that next screen, or that next button. I can't hit either one of these because I've recognized every part of the body that was imported. Again, if there was patterns or things, I can have them combine them as well. So I clean up my feature tree. Once I hit OK, it actually builds this thing. And you can see I'm not using my mouse and keyboard. It's doing this right now. So it looks like it had to create a plane. Maybe I picked the wrong thing when I did the extrude or the revolve or something. But basically, it created native SolidWorks features for me pretty quickly. And, I can come in here and I can edit these things. I can change radius values. Again, with my draft, if I wanted to draft that, it was at a 30 degree. I can change it to a different type of draft, a different angle, those types of things. So it's very easy now to come in here and, let's take this original boss extrude and, or which one was it? Yeah, this sketch here. And I'll just change it so you can see it update on screen, basically. So, again, very easy to add these parts, to change them. You just got to really decide on what you want to do in there. So, again, once you use FeatureWorks, it's the nicest way to get it because you get this native SolidWorks stuff. But really, dude, you need to spend that time to do it if all you needed to do was change the hole or something like that. I know I use simple parts. I want to keep this quick for this webcast. But all right, so basically, hopefully, that's pretty much all I had for you guys today. I'll answer questions now. But the main topic here, what can we do with our legacy data? Is answered with the 2D type stuff, and with the 3D. I think the most important thing to get across is the data is not going to expire. It's there. It's good, unless it's in some proprietary format or something that you need to get it out of. Otherwise, the DXF, DWG, the SolidWorks files, the ProE files, all those things that you can import, all those different file types, they're always going to be there. So you can always bring those in. So thinking you need to convert everything over because you're switching CAD packages is misleading. You really don't need to do that. Your data probably isn't going to expire. I can't imagine a world in CAD where we won't still have a DXF somewhere or a DWG type reader or something like that, or the ability to import. In fact, I think the only thing you're going to see is importer tools get better and better and less translation type errors and stuff. So anyway, I'll go ahead and open it up for questions here. If anybody who's still around has some questions, let's go ahead and type them in. Maybe I can help you out with those. Otherwise, thanks for attending, and feel free to contact us anytime.